Hey guys, welcome to a video on rewriting standard form of quadratics in Vertex Form. To help you find what you need, here are the timestamps. They're also linked below in the description to help you find them easier. While the three main forms of quadratics are standard form, factored form, and vertex form, this video is focused on converting standard form to vertex form. Remember, standard form is f of x is equal to ax squared plus bx plus c, and vertex form is f of x is equal to a times the quantity of x minus h squared plus k. While the c value in standard form gives you the y-intercept right away, the h comma k in vertex form tells us where the vertex is of our parabola. Since a lot of quadratics word problems ask for a maximum or a minimum, it's useful to convert from standard form to vertex form because h typically stands for when you're at your highest or lowest point, while k tells you where your highest or lowest point is. If you'd like me to make a video on application problems of quadratics, feel free to like, subscribe, and comment below with the topics you are interested in. Let's get into converting standard form to vertex form. In example 1, our a value is going to be 1 and our b value is going to be even. Just to be clear, there's a 1 here and there's an even number of 12. Let me start here by clarifying that we are starting off with standard form. Let's start off by grouping the first two terms together. 11 is going to feel left out for a little bit, but it's going to come back later to help us. Once grouped, I'm going to rewrite our function, but this time I'm going to leave a little space. I'm going to write x squared minus 12x. I'm going to add a plus. I'm going to leave a blank here and close our parentheses. Outside, we still have our sad 11, and we're going to subtract the same blank we had inside the parentheses. Since we're going to be adding and subtracting the same value, this won't change the value of our expression at all. But what is this value that we're going to be adding and subtracting? It turns out this value is going to be 36. The way to get this value is by looking at this b term. Here we can see that b is equal to negative 12. To get the 36, you take b and you cut it in half, and then you square it. Since b is negative 12, we're going to substitute that in. Negative 12 divided by 2 squared. Negative 12 divided by 2 is going to be negative 6. And if we square negative 6, that does equal 36. This process is called completing the square. The reason why we added 36 and completed the square was so that we would get a perfect square trinomial. Completing the square and adding this 36 allows us to rewrite this as x minus 6 times x minus 6 plus 11 minus 36. Since we have two identical binomial factors here, we can simplify this by writing the quantity of x minus 6 squared. As for that poor 11 that got left out earlier, 11 is going to subtract 36 to get negative 25. Our rewritten function here is going to be f of x is equal to the quantity of x minus 6 squared minus 25. This is vertex form. The h comma k in this particular function is going to be 6 comma negative 25. Since our a value was a positive number, this ordered pair represents the minimum of the parabola. In example 2, let's try a similar example. First I'm going to rewrite the function, but I'm going to group the first two terms again. You're going to have x squared plus 14x. I'm going to add a missing value here. The negative 15 gets left alone on the outside. We're going to subtract the same value that we added earlier. This way we're not changing the problem at all. To complete the square, we're going to take the b value, which is 14, divided by 2, and then square that. 14 divided by 2 is going to be 7, and if we square 7, that's going to be 49. To complete the square, we're going to add a 49 over here, but to keep the expression the same, we're going to subtract 49 over here. Factoring this perfect square trinomial, we can rewrite this as x plus 7 times x plus 7. Combining these constant terms out here, we can rewrite this as minus 64. Since we've completed the square to make two identical binomials, we can rewrite this as the quantity of x plus 7 squared minus 64. This equation in vertex form is f of x is equal to the quantity of x plus 7 squared minus 64. See if you can tell what the vertex is. In example 3, a is still going to equal 1, but b is now going to be an odd number. Based on the last two examples, think about why that might not be so good for us. Alright, I won't spoil it yet, but I think we'll find out soon. Just like earlier, I'm going to rewrite this function and I'm going to group the first two terms together. This x squared minus 3x is going to be grouped together. I'm going to be adding some unknown value to complete the square. On the outside of this grouping, we still have negative 4, but we also have to subtract the same value that we were adding. Let's find out that missing value by completing the square. Let's take half of the b term, which is negative 3, and then we're going to square it. Squaring a fraction is easier than you might think. you just write the fraction -3/2 and multiply it by -3/2. Squaring -3, we're going to get a positive 9, and squaring 2, we're going to get 4. The reason why I'm going over this example is because squaring a fraction can be a little bit challenging sometimes. To complete the square, we're going to add 9/4 inside here, but to keep things balanced, we're going to subtract 9/4. Now that we have our perfect square trinomial here, we can rewrite it as two identical binomials. They're going to be x minus 3/2 times the quantity x minus 3/2. And over here, we need to figure out common denominators to add or subtract these fractions. This -4 here is the same thing as -4/1, and multiplying the top and bottom by 4, we're going to get -16/4. Let's rewrite it as -16/4 minus 9/4. Rewriting our two equivalent binomials, we have the quantity of x minus 3/2 squared, and since -16 minus 9 is -25, we're going to have -25/4. In vertex form, this function is equal to x minus 3/2 squared minus 25/4. While we typically write our equations using improper fractions, remember that this 3/2 is really just 1.5, and this -25/4 is really -6.25. If you prefer working with decimals, this may help you out. In example 4, we're going to try a function where a doesn't equal 1. Let's see how this 2 affects our process. As usual, we're going to start off by just grouping our first two terms here. We're going to group 2x squared and 12x in the same parentheses, and leave this plus 7 on the outside. Since this 2 here is not a perfect square, we need to factor it out. Factoring a 2 out of our parentheses, we're going to get 2 times the quantity of x squared plus 6x. And we have a plus 7 out here. Now let's expand this a bit so that we can complete the square. We have 2 times the quantity of x squared plus 6x plus some unknown. We have our plus 7 on the outside, and if we added some unknown, we got to subtract the same value to keep everything balanced. To complete the square, we're going to take half of our b value, which is 6 here, and then we're going to square it. Half of 6 is going to be 3, and 3 squared is going to be 9. To complete the square, we're going to add this 9 inside here. While we added a 9 inside the parentheses here, don't forget about the 2 that was in front. This 2 in front of the parentheses really means that we added 2 of these 9s into our function. If we added 2 9s on, or 18, we should subtract 18 to balance it out. Now that we have a perfect square trinomial, we can write this as 2 times the quantity of x plus 3 times x plus 3, and we can simplify this positive 7 and negative 18 as negative 11. Now that we have our matching binomials, we can simplify this a bit further. We can write this as 2 times the quantity of x plus 3 squared minus 11. In vertex form, our final function here is going to be 2 times the quantity x plus 3 squared minus 11. Just as a quick spot check, notice that this 2 over here matches the 2 that we had in the beginning. These a values will always match despite converting forms. And here's one last one. In example 5, a won't equal 1, but b will also be odd. Let's see what happens here. First, I'm going to group our first two terms, which is going to be 3x squared plus 15x. I'm going to close that parentheses and write the plus 20 on the outside. Since we need a perfect square at the beginning of our perfect square trinomial, we can factor out a 3 here and write this as x squared plus 5x. Outside, we still have the plus 20. Now that we have a perfect square in the beginning of our parentheses, we can now try to complete the square. We have x squared inside plus 5x, and we're going to add some value here to complete the square. We still have a plus 20 on the outside here, but we're also going to have to subtract some value out here to keep things balanced. To complete the square here, we're going to have to take half of 5, which is the b term, and we're going to have to square that. Squaring 5 over 2, that's going to be 25 over 4. We're going to add 25/4 inside here to complete the square. Although we added 25/4 inside the parentheses, we really added 3 of those onto this function. 3 times 25/4 is 75/4, just because 3 times 25 is 75. Now that we have a perfect square trinomial, we can rewrite the first part of this function as 3 times the quantity of x plus 5 over 2 times the quantity x plus 5 over 2. To combine these two like terms, we need to get common denominators. This 20 can be rewritten as 20 wholes, and to get common denominators, we can multiply by 4 on top and bottom to get 80/4. Here we have 80/4 minus 75/4. Since we have our matching binomials here, we can simplify this a bit more. We can write 3 times the quantity of x plus 5 over 2 squared plus 5/4. I got the 5/4 from subtracting 80/4 minus 75/4. In vertex form, this equation can be represented as f of x is equal to 3 times the quantity of x plus 5 over 2 squared plus 5 over 4. Once again, notice that our a value here of 3 matches our a value that we started with. I hope you found this video useful in understanding how to convert standard form quadratic equations into vertex form. By completing the square and using other little algebraic tricks, it was my goal to make it as clear as possible on how to convert these two forms of quadratics. If you found this video useful and are looking for more math videos in the future, please like and subscribe to this channel. Keep up the good work, and I'll see you in the next one.